Hello good day viewers. In this tutorial we are going to learn how to find the modulus of a complex number, which is sometimes called the absolute value of that complex number. The modulus of any complex number is just the distance between that complex number and the origin on a graph. I think I should explain this before we start solving these problems. Suppose we have a graph like this and we have a complex number right here, which is called a plus bi. You know, this is the imaginary part and this is the real part. A defines the real part and B defines the imaginary part. At that point, we have B here and we have A down here. So what we are actually looking for is the distance between this point and the origin, which is this straight line. And if you observe, we have a right angled triangle because this is 90 degrees and we have our acute angle right here. This means that we can apply Pythagoras rule to find the distance between these points. If this point is B and we have seen that this point is A, we can call this one Z modulus or D. It doesn't matter. So Z modulus, which is the hypotenuse, is equal to the square root of A squared plus B squared. So this is the formula we're going to apply while finding the absolute value of this complex number or the modulus. All right, let's get started. The first question, A. So 1A, we are given that Z is equal to 2 plus I. 2 plus I. What will be the Z modulus? Z modulus will be the square root of A squared plus B squared. A here is 2 squared and B is the coefficient of I, which is 1 squared. 2 squared is 4, 1 squared is 1, so 4 plus 1 is 5. So this turns out to be square root of 5. As simple as that. Then let us take the second one. We have Z equal to 7. Z equal to 7, which is the same thing as 7 plus 0i because the imaginary part is 0. So Z modulus, or the absolute value of Z, is equal to the square root of 7 squared plus 0 squared. 7 squared is 49, 0 squared is 0, 49 plus 0 is 49, square root of 49 is 7. So this is equal to 7. Then 1C, we have Z equal to 8 minus 6i. 1C, Z equals to 8 minus 6i. Therefore, Z modulus is equal to the square root of 8 squared plus negative 6 squared. Let me simplify this a little bit. 8 squared is 64. So we have 64. Negative 6 times negative 6 is 36. Combine this together, you have 100. So this is 100. And square root of 100 is equal to 10. Therefore, Z modulus is equal to 10. So I want you to try the rest of these two questions. We have Z equal to negative 6i. And we have Z equal to 3 multiplied by 2 minus I. The only hint I'm going to give you here is that here we have 0 minus 6i, which implies that the real part is 0. And the second one, you have to expand this parenthesis. 2 multiplied by 3 is 6. 3 multiplied by I is 3i before you take the absolute value. So we have another question here that stated that if Z is equal to A plus 3i and the modulus is what? Square root of 13, we're asked to find A. Let me just copy the question. So this is the question. First of all, we know that Z modulus will be equal to the square root of A squared plus what? 3 squared. But Z modulus is given as what? Square root of 13. So we equate this to be equal to square root of 13. This means that A squared plus 3 squared, which is 9, must be equal to this 13. So you take 9 to the other side, we have a squared equal to 13 minus 9. And a squared is equal to 4. So to find a, you can take square root of both sides. A finally will be plus or minus square root of 4, which turns out to be a equal to plus or minus 2. So a could either be positive 2 or negative 2. Then the last question, we have z equal to 3 minus bi, but the absolute value of z is 5. We are asked to find b. We have z modulus to be equal to the square root of what? 3 squared plus negative b also squared. But the z modulus is given as 5, so you equate this to be equal to 5. We have 9 plus b squared equal to 25. And you know negative b squared is just b squared. Take 9 to other side, we have b squared equal to 25 minus 9, which is 16. Take square root of both sides. Finally, you can see that b is either plus or minus 4. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.